track with it now. So let's pick it up. Down. Pick it up there.
It like manually closes it all the way.
All right, so I just shut the whole thing down and it's back up. All right, so we're on number 12. So let's try number 12. All right.
Yeah, are you going to time 12 is exactly like 11?
Yeah. Let me just whip it out without. Oh, I forgot. When you turn it off and on, you got to realign your Apple Pencil. Sorry, technical difficulties here. Right. Yeah, go ahead and try it. Did you see it? It's off the screen while I. Should be enough time. Let's see. All right. Okay. Hey, we're working. All right. So, yeah, this is going to be the same thing again. Yeah. I'm just going to go with what. Yeah, it's the same thing. Very, very similar. Same thing. So I'm going to move on to number 13. So number 13. How do we do number 13? Find the center, transverse axis, vertices, folks. Okay. So they want me to do everything for this one. So how do we do it? What's the center? Yeah. Opposite. So back 4 up 2. Right there. Back 4 up 2.
And then you can eliminate C.
Is that true? I haven't even looked. Let me. I usually do a couple steps before I even start looking at options. Back 4 up 2, that's the center. And whatever's underneath X, that's right, left. And that's 5 squared. You with me? 5 squared. And what's underneath Y is 6 squared. So right, left, 5. So that'd be 1, 2, 3, 4, 5 to the right. And 1, 2, 3, 4, 5 to the left. And then up 6. 1, 2, 3, 4, 5, 6 up. And 1, 2, 3, 4, 5, 6 down. And make a dotted box. And then fill in the diagonals. I'm going to run out of room here. And where do the branches go? Up, down, or right, left?
Up, down.
What's in front?
X.
Right, left. Right? Because X is in front, right, left? We good there? So branch here, branch there. So good for the general shape. Am I going too quick? So you find the center, opposite, back 4, up 2. You see how I found that center? Back 4, up 2, right there. And then whatever's underneath X is 5 squared, 6 squared. So I went right 5, left 5, up 6, down 6. Because what's underneath X is right, left. What's underneath Y is up, down. I made my dotted box and filled in my diagonals. And the branches go right, left because X is in the front. Whatever letter's in the front. It's a hyperbola. All right, now what do they want to know from me? Let's see, can I start eliminating? Center is negative 4, 2. A's right so far, negative 4, 2. Yeah, C's out. The center's backwards, huh? That center is not good. So C's out. Transverse axis is parallel to the X. Is that right? Yeah, it's a sideways one, right? So it's parallel X. That's good. The vertices, I don't know what the vertices are. Looks like they all have different vertices. So I got to find these vertices here, don't I? These two vertice points. Why is D out?
Because it's Y-axis.
Oh, Y-axis. I didn't see that. Yeah, D says transverse parallel to the Y. So D's out for that reason. Good. So D's out, C's out. Now, what are the vertices? Let's find the vertices. You've got to take the center point, which is negative 4, 2, right here, negative 4, 2. And then you've got to go 5 to the right and 5 to the left on the x-axis. So 5 to the right and 5 to the left on the x-coordinate. What do you get? 9, 2? No. 1, 2. That's 1, 2, huh? 1, 2, right? Negative 4 plus 5. Y'all with me? Am I going too quick? And then negative 4 minus 5 is negative 9, 2. Those should be the two vertices. Minus 9, 2 and 1, 2. That looks right. B's looking good so far. I have to check the foci points to be 100% sure. But B is looking right so far. A's out, wrong vertices. Is that too quick? Do y'all see how I found the vertices? I took the center, negative 4, 2, and I added 5 and subtracted 5 to the x coordinate. Because what's underneath x is 25, or 5 squared. So that's add 5, subtract 5 from the x value. Right? So negative 4 plus 5 gave me positive 1. And negative 4 minus 5 gave me the negative 9. Isn't that good? So the vertices are the main distinguisher, it seems like. So it's B. Is there even an E on this one? There probably is. Huh? So it's either B or E. Last thing is the focus points. I'm going to move on. Is that okay? I mean, well, oh, screen. Huh? Yeah. How do you find focus?
H plus or minus D.
Yeah, the Pythagorean thing. Pythagorean. I need a fresh screen here. So Pythagorean. Yeah. So for the focus points, a squared plus b squared is c squared. There's minus in the main equation, so there's plus in the focus equation. It's always the opposite sign in the focus. Okay, so how do you find it? What's the a and the b? What's the 25 and the 36? Huh? Well, not squared. It's really, this should have been written. I just was too quick here. 5 squared, 6 squared. So this is 5 squared, 6 squared is c squared, 25. 36 is c squared. That's what, 61? 61 is c squared. Root it. So root of 61, yeah, looks right, huh? Minus 4 minus root 61, minus 4 plus root 61. Yep. They took the center and they did that. So, I'm looking at B, huh? B has the same thing. So B is right. B is the answer. Good. I'm going to move on. We good with that one? Okay, so 14. So y plus 4 squared minus 9, x plus 4 squared is 9. So what do we do to take this hyperbola and put it in right form? Got to get a 1 on the right side, don't we? We've got to get a 1, right? So divide by 9. So we get y plus 4 squared over 3 squared minus x plus 4 squared over 1 squared. I'll just make that 1 squared down below to give it the right look so we know how to graph. Is that good to there? Now there's no E. Here we go, no E. So it's just A, B, C, D. So yeah, what's the center? Yeah, let's talk about the center. The center is, opposite, negative 4, negative 4.
Not that they're all going to be the same, but can you just do process of elimination and be done with it?
I would. Yeah, since there's no E.
Well, not just that, but if you look at the centers, there's only one center to match the center.
I think this one matches and this one matches. They both have the right center.
One of them's going with y out front, so it can't be
Yeah,
A.
so then that fact too
And
puts
then,
it together.
Yeah, those two, so then it's got to be D.
Correct. So y is in the front. So both these have the right center. Everybody with me on that? See how those both have the right center, minus 4, minus 4. But y is in the front, so it's up, down, so it is D. Good? On that, we don't have to mess with anything else. It's up, down, it's got the right center. How we doing? We good? All right, find the equation for the hyperbola. We got the vertices and the focus points. Okay, so probably need to draw this thing, huh? So let's do that. So the vertices are 7, 0, and minus 7, 0. Those are vertices. And the focus points are even further. Bless you. So, so the branches have to be going right, left, don't they? because the focus points are inside the branches. All right, so what's the equation then? Well, it's got to be x squared over 49, doesn't it? Because it's right 7, left 7 for the sideways. So it's got to be x squared over 49. So it's not C, it's not D. We good so far? Now, what is y squared over? How do we find the y?
Using the focus.
Using the focus equation. Am I racing ahead of you? You guys okay? Tracking on this? So it's, to find the y, to find whether it's A or B or none, we got to look at what's under y. One of them has a 121. One of them has a 72. Which one's correct? Well, we got to do the focus equation. And so let's do that. So come over here, do the focus, which is A squared plus B squared is C squared, right? We have minus in the main. We have plus in the focus. So it's the opposite sign in the focus equation. What's the idle? One of them is 7 squared. And the C, what's the C?
Is that from center to focus?
Yeah, center to focus. That's always C. 11 squared, huh? We good there? Not making sense? So again, you got to be really clear what A, B, and C are. A and B are from the center to the edge, right? So from center to the vertice, that's 7. So that's A, or you can put it in B. It's interchangeable, doesn't matter. It's A or B. It's one of those. So from center to the edge of the shape, that's A or B, whichever way you want to call it. And from center all the way to focus point, that's C, isn't it? For all these graphs. All right, so then we got what? 49 plus B squared is 121. Subtract 49. B squared, what is that? 51, 72. So B is the root of 72. Whatever. B squared, 72, right there. It is B. We good? See how we eliminate that through process of elimination? Questions I can answer on that one? Yeah, remember the whole, for hyperbola, it just matters which one's in the front. It doesn't matter which one's bigger. So the one that's in the front tells you if x is in the front, right, left. If y is in the front, up, down. Doesn't matter which one has a bigger number in it. That's ellipse, which really matters which one has the bigger number. That's the major axis for an ellipse.
That's the A squared, right?
Well, I didn't sweat it. I think the book did. Yeah. Oh, yeah. It's in the focus form. It's got to be the A. Yeah, that's true. Right. The bigger one's got to be in the front. Okay. So 16. Use a graphing calculator. Did you notice those words? So in other words, we're not going to do this one by hand. Don't waste a bunch of your time trying to solve this thing by hand. It's not going to happen. So in other words, just take your calculator, put this in for y1, put this in for y2, graph them, and hit the intersect button. And hit enter, enter, enter. And it's hopefully there. So did you get that? So put in for y1, put in for y2. So y1 is e to the x. And y2 is x squared. Graph them. And hit second calc, go down to intersect. Enter. I got x equals negative 1.147. Yeah, none of the above. 7758. You guys get that answer? There it is. If you have any trouble getting that graph or anything, grab me after. I'd be glad to help. My window was just normal, which means x min negative 10, x max 10, y min same thing.
We won't see anything on the test where there was 2 intersections after, right?
Yeah, there can be 2 answers. Yeah, we had that in the homework. A couple times when they have a couple answers listed there. You'll see it on the graph. You just find them both. Yeah, on that. All right. Okay. 17. Yeah, how do you take this one log and turn it into several logs? Well, remember the rules, right? So it's going to be log 19, 10 through to 7 minus, oh, this has a little trick. Let me help with that. Y squared minus log 19x. So far, so good? So dividing, like this fraction here, dividing became subtraction. Now, one thought, you might think, now wait a minute, if I was you, I'd probably think, no, wait a minute, Mr. Heron, this is multiplied down here. This is y squared times x. Yeah, shouldn't that be plus? Didn't we learn that multiply is plus? Well, yeah, it is plus, but really it's like this. Because they're both together on the bottom. So really it's minus both of them. And what does that minus 2 do? Distributes to both of them. So in the end, they both end up negative. Negative. Do you all see that? Right? Because we learned that multiplying is adding, dividing is subtraction, right? Well, the trick on that one, the extra trick on that one, is that both of them, on the bottom there, both of them are underneath the fraction. So you're subtracting parentheses the whole thing, right? Because you're dividing by both of them. So really, I would just jump to here. Let me give you a simple rule to make life easy. Anything in the denominator is going to end up having minus in the front of it in the end. Anything in the numerator is going to end up having plus in the front of it in the end. That'll always be the case. You can count on that. That's really the fundamental rule with logs there. Numerator stuff, plus in the front. Denominator stuff, minus in the front. Does everybody see that? That'll really be the case. Yeah?
So if that second one had a plus, like would it be safe to say that you should group them based on signs? Would that give you the correct answer? Like not speaking about this question specifically, but in general. Like
the order doesn't matter. You can mix up the order anywhere you want. It's just the sign in the front matters. So anything in the denominator is going to have a minus in the front of his log, wherever he says.
So if that was like without the parentheses, if that was like plus log base 19 to 10 or 10, that would be multiplied by the very first value?
You mean if this was a plus here?
Yes.
If that was a plus there, yeah, that means it's in the numerator. That would mean it's really 10 through to 7 times x. It would be up there.
Okay. That makes
That's right. Anything with a plus in the front of the log really is a numerator player. It doesn't matter what order the logs are in, right? You can rearrange order anytime you want. Is that making sense? So that's really how you want to think about that rule. The rule we learned about division and subtraction. Really, it's any log that has a minus in the front, those pieces are denominator. And any log with a plus in the front, that's numerator.
It could be negative for logs, right?
We're not talking about inside the log.
Yeah, I mean on the equation itself, it's like the fraction. It can't be like a negative some log 19 negative fraction, right?
You cannot have negative inside of a log.
Okay.
Okay, now last thing, this 10th, what do you do with this 10th root? What's this 10th root do? That's a 1/10 power which comes from it, right? Do you remember that roots are fraction powers, aren't they? So that's a 1/10 that comes to the front. And this 2 comes to the front. And that's it. Everybody good with that? I don't know what answer that is. Is it A? They're all so close. Is it C? Yeah. Yep. Good. A just has this bad part right there, huh? We good there? Remember those rules on that? And then 18 is the same thing, kind of, just going the other way. 18, we want to crunch them all together. Yeah, I'm going to skip 18. I'm not going to make it. So I'm going to skip 18. I'm going to go on to 19. 18 is the same thing, just run it backwards. I'm going to calculator 19. Yeah, the top one goes on the top, the bottom one goes on the bottom. Make it 2 logs. Hit the buttons. Whatever you get, you get. So
Top goes to top, bottom goes to bottom.
top goes top, bottom goes bottom. I'm getting 3.126. Yeah, A. There it is. On we go. All right, 19. Find the amount that results. Actually, 20 is easy. I'm going to go on to 21. 21. 6% compounded monthly. Find the effective rate. How do you find effective rate? What do you do for effective rate?
R equals 1 over 1.
Yeah, there's the 2 formulas. I'm going to give you at the top of the exam. I forgot to put it at the top of the practice exam. I'm going to give you 1 plus R over N to the NT, and I'm going to give you PERT. So those will be right at the top of the exam. And so which one do I use for number 21 here? 6% compounded monthly. Month. When do I use PERT? PERT is for continuous. Yeah, continuous. Continuous, or it's for all the growth decay problems, huh? All the growth decay problems use the PERT and continuous compounded interest. This is monthly, so I'm going to use the other formula. A equals P, 1 plus R over N to the NT. I'm going to use that one. Okay, 6% compounded monthly. What do you do for effective rate? That's what the book did. I didn't do that. That's fine if you know how to do that. But what I said is put in $1 for T is 1 year. Put in $1 for 1 year. So $1 for 1 year. Because we're trying to say what's the real effect of a 6% account compounded monthly. It's going to come out a little higher, a little bigger than 6%. But how much bigger? Well, if you can find out what happens to $1, you can find out what happens to every dollar, right? So that's the whole reason this works. Just put in $1 for 1 year. Find out what happens to that $1. Like if I told you, hey, that $1 became $1.07, then you go, oh, it grew by 7%. You would know, huh? And if that happened to that $1, that'll happen to every dollar. You would know the whole account's going to grow by 7%. All right. Anyways, that's the deal. So I'm going to use this. I'm going to put in. So the amount is going to be P, $1. R is 6. Compounded monthly. That's N is 12. 1 year. There we go. So I put in $1 for P. 1 year. 6% compounded monthly. So hit the buttons on your calculator. To the power of 12. I'm getting 1.0616777812. And then last step, so put in $1 1 year. Now subtract the original $1. Remember, because we just want to know the growth. We just want to know how much it grew by. So we want to take back out that original dollar. So just cancel out that dollar right there. And then you got to change it to a percentage. All these answers are percentage. So move the decimal 2 places. 6.1677%. They're rounding them to 3 places, so it's A. 6.168. Are we good there?
Because I use a different formula, where did you put, well, same formula manipulated, but where did you subtract 1 at?
I just canceled the 1 out right here. This is where I subtracted the 1. Is that good? So effective rate, so want to have this on your 3x5 card. Effective rate is $1 1 year and then subtract the original dollar. Because you just want to know the growth. All right. So jump 23. What is the annual rate of interest required to triple an investment? Yeah, this problem, they should have said, this is a bad problem. The publisher didn't do a good job here. compounded annually. They should have said how frequently it's compounded. They forgot to. Compounded annually. It's not enough to say what annual rate. All the rates are annual. You got to tell me how often it's compounded. Compounded annually as well. So they meant to say that, they blew it. All right, so here we go. With that information, let's try it. 1 plus r over n to the nt. So we're going to use that formula. Why do I not use the PERT? That's continuous.
But A is 3P, right?
Right, and the A is 3P. Good job, because it's triple. So the amount will come 3 times. The rate is what we're looking for. The N is once a year. That's the part they didn't tell me. Compounded annually. N equals once a year. For T equals 11 years. Good to there? What's the first step for solving that thing? Get rid of P, huh? Boom and a boom. 3 equals 1 plus r over 1 is just r to the 11th. Good to there. Now, how do I solve that thing for r? Good job. Yeah, are you all comfortable with that? When you have a number in the power, do 1 over number both sides, or the root. Oh, I'm probably off the screen there. Both. Am I back on? Look, it adjusts. Look. It's all lined up now. It just kind of moves throughout the hour, doesn't it? It's got a mind of its own.
I think it's between you switching the screens down there.
That help when I move the screens? All right, both sides. So, or the root, same thing. So, so I'm going to come in here and go, okay, 1 over 11, 1 over... Why don't we do ln? When do we do ln on both sides?
When variables time.
When the letter gets into power. So if this was like a t up there, or an x, or something like that, then I would do the ln, right? That makes sense? But if it's just a number in power, you just do 1 over the number. These cancel, and we get 3 to the 1/11th is 1 plus r. Is that good? And then just subtract the 1. If you did the 11th root, that's the same thing. That's fine too. So there we go. So then use your calculator. 3 to the 1/11th. And I'm getting 0.10503 15 blah blah blah. Move it. That's a decimal. Move it 2 places to make it a percentage. 10.5%. That's not even there. None of the above. Questions on that one so far? We good? We got to do these last 3 or 4. Oh yeah, I did it all by itself, huh? Yeah, somebody. All right, 24, strontium. Blah, 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 blah. Here's the formula. P equals P0 e to the minus 0.0244 T. How long will it take for 15 grams to shrink, decay, to 5 grams? All right, so where do I put the 15? P0, huh? Yeah, the 15 goes right there. And the 5 goes out there, doesn't it? Is that making sense? Everybody see what I did there?
Yeah.
Right? You get the hang of that PERT formula. That's basically the PERT formula. They're just calling the different places a little by different names than we did, right? Than I did. I always used PERT, right? I always called this A, and I called the other one just normal P, didn't I? But are you comfortable with... Do you know what a sub-zero means in any formula? If you're going to take any science, biology, chemistry, astronomy, any kind of science, what does a letter with a sub-zero mean in any science class? At time 0, initially, right? I mean, P at time 0. That little 0 means time 0 at the start of the whatever thing you're doing, huh? So, yeah, that's how I know the 15 goes there, because that's what it starts at. How long for 15 grams, starting at 15, to later become 5 grams, decay to become 5. So that's why the 15. All right, so now we just got to solve for T. How do we solve that for T? What do I do? Divide by that 15. Now that's 1/3. If you want to make it a decimal, you better use a lot of places because you're not done with the problem yet. Y'all hearing me on that? I don't want you to get messed up on the decimal rounding thing. So really it's best to just make that 1/3. Remember, you don't want to round in the middle of a problem when you have more work to do. You don't want to round because it'll throw off the other answers. And if you round really abruptly, with just a couple digits, you're going to get pretty far off. So if you're going to, I would use a whole bunch of 3s. So if you're in the middle of a problem and you have a decimal that goes forever, well then use a whole bunch of spots because you still got to do more stuff with that thing. So don't just write 0.33. You'll get something rounded pretty far off because it's really 3s forever. So use a whole bunch of 3s like that. Is that making sense? What do I do now to solve for t? Yeah, ln. Why ln this time? Because the letter, Hitler's climbed into power. The letter has got into the power zone, right? Cancel it out. So minus 0.0244t is ln with a bunch of 0.3s like that. The last step, now it's easy. Just divide by minus 0.0244. Hit the buttons on the calculator. Does it come out? Somebody got it?
So we can't leave it as a fraction.
Oh, 1/3? Or 5/15ths?
Yeah.
Yeah, that's even better. That's even more accurate. No, that'd be great. I'm getting 45.0. 45.025. 45.0. Yeah, so D, it rounds to 45.03. There it is. Good on that one. I move on from there. Get through these last couple. Bless you. All right, 25. All right, so 25 is a hard one. Conservation has tagged the 80 rabbits in 2009. 2012, 3 years later, it was 160 of them. How many in 8 years? All right, so which formula are we going to use? PERT. Always use PERT on these populations growing, shrinking, chemicals growing and shrinking. Always use PERT because things happen continuously. They don't just go year by year or something. All right, so here we go. What do you do with that 80? Where's the 80 go? That's our P, right? That's the initial amount. That's the amount at first. So the 80 goes right there. That's the amount at the start. 2009 is, so when they say 80 in 2009, that's the start. That's all they're giving you when they tell you that. They're just saying, hey, at the start, we had 80 rabbits. We started in 2009, and we had 80 rabbits. So that's your P. And then remember, these are in 2 phases. Phase 1 is all about finding R. And then phase 2 will finish the problem. So how do we do that? 2012, there was 160. That's 3 years later, isn't it? That's 3 years later. So that means when t is 3, the amount was 160. Kind of scribbling there. Y'all tracking with me? When 3 years later, the amount, so when time is 3, the amount is 160. So now I've got to find R. That's phase 1. Solve that thing for R. How do you solve for R? Divide by the 80. Boom. 2 equals E to the R times 3. Good so far. What do I do now to solve for R? ln, because R is in power, huh? Cancels out. Take ln on both sides, cancels out. Last step, divide by the 3. So there's R, it's ln 2 over 3. That's phase 1. That's just the first part of the problem. Now, coming up here for phase 2. So R is ln 2 over 3. So go back to the PERT formula. This time, put in, again, P is 80. R, I now know, is ln 2 over 3t. Kind of running out of room. I'm going to make this a little better. Is that good? Last thing. Now I'm ready to finish the problem. So everybody see I'm over here in phase 1. I found R. Now this is phase 2. Phase 2, I'm finishing the problem. What am I going to do to finish? They want to know 8 years later. Put in 8, huh? 80 e to the ln 2 over 3, 8. Stick in an 8. Hit the buttons on your calculator. I think it's none of the above, isn't it?
You know, all these E's add about 20 minutes to test taking time.
Double checking and being sure, huh? I'm getting 507.
Yeah.
507.96 of them are rabbits, and that's not even there. None of the above. All right, we got to squeeze in one more. You good with that? Questions on that one?
I know, there was a lot.
Asked me to do it, so I just did it itself and stuck it online. So that's up there. 27's up there. Let's look at 26, and we'll be done. Of course, I didn't do anything from part 1, but part 1's up there from earlier semester, right? All part 1's there. So, all right, so finish this up. We should be in good shape. So number 26 here. How do we do it? Fossilized leaf, 13%. So, remember remember the half-life? What did I give you for half-life?
It's something 0.5 or something.
Yeah, for half-life, I gave you a tip so you don't have to do phase 1. R is always going to be ln of 0.5, there's your half, 0.5, over the half-life. So in our case, it's ln 0.5 over the 5600, because that's the half-life. Right? So I gave you that tip so you can skip phase 1 when they tell you half-life. You got your R automatically, which is normally what we have to do in phase 1. So here we go then. So I can jump right into phase 2. So PERT, what's the P? I'll get back to that. The R is ln 0.5 over 5600 T. Now, a fossilized leaf contains 13% of its normal. That means the amount is what? 0.13 P. Everybody see that? That's what it means to have 13% of your normal original amount. 13% of P. P is the original amount. Is everybody good with that? I often see the mistake. People will forget the P, and they'll just put 0.13, which is okay if you get the P, rid of the P on both sides. That's right then. Right? But it's there on both sides, and it cancels out, huh? But don't mistakenly put it only on one side. So gonzo, e to the ln 0.5, 5600 T. How do we solve for T? What do we do? ln, our good friend ln, cancels out the e. So bring it up here. ln 0.13 is ln 0.5 over 5600 T. How do you finish? Divide by ln 0.5, divide by ln 0.5, boom, boom. And then we get ln 0.13, ln 0.5 is T over 5600. Last step, just multiply by the 5600. And you got it. So there it is.